Welcome back to the next Unit 2 video. As you can see, today we're going to look at network topologies. So just a quick overview of what we're going to cover. Well, we're going to look at the point-to-point, the point-to-point topology. The bus, the full and partial mesh, the star and hybrid topology. Right, then we're going to look at the advantages and disadvantages of each. We're also going to look at the 5 requirements that make up a digital communication system. We're going to look at the 3 communication modes and 3 transmission modes. And briefly, so briefly we're going to look at some of the different transmission mediums, and this can be, for example, either physical wires, or it can be, I suppose, kind of like physical properties, things like radio waves, of course, Wi-Fi. Right, we'll also look again, briefly at some of the network hardware, and we'll also see, what's a collision and what are terminators, or what terminators are used for. And the reason I say briefly is because, these parts are actually different chapters. Okay, So I guess we can say, these are later chapters, in this unit. However, we do kind of need to understand some of these, of course, in order to understand some of the stuff we're doing today. All right. So first of all, let's actually think, what is a topology? Now, if you're familiar with maps, then maybe you've heard the term, the sort of topological landscape, or maybe the sort of topology of the environment, something like that. And in that case, basically it's just talking about the hills, it's talking about the mountains, the canyons, right, the valleys. So we can kind of say like the altitude. Now, it's kind of the same for for a network, where here again, we're also just talking about the physical layout. If we just read this, where it says the physical and or logical layout of a network. Right, then before we need to know, as mentioned, right, the point-to-point bus, right, star, right, mesh, this comes in 2 variations, the full and partial mesh, and finally just hybrid. Now, you might be thinking, of course, here it says 4, but, of course, here there's 5. Now, the reason for, so the reason I say 4 here is that because, these 4 are just the main ones. Now, hybrid, this is actually just a combination of some of the other 2. This is not really a kind of distinct network, right? It's just a combination. So first, let's look at some key concepts. And I think, as mentioned, then we want to look at the 5 requirements for a digital communication system. Right, first there has to be a sender. Of course, someone sending the data. Of course, if there's a sender, there has to be a receiver. Right, otherwise you're just sending it into the void. Right, there also has to be a transmission medium. This could be Wi-Fi, could be twisted pair. Now, when we say twisted pair, some people kind of call this Ethernet. They might say, I don't know. Okay, maybe they say, plug in the Ethernet cable to the desktop. Just to connect it, to the router. However, I think, if you say Ethernet cable in the exam, probably they wouldn't really accept that. I think for the exam, right, they're going to want you to say twisted pair, which is kind of the more formal name. Right, coaxial, this was actually used for the old radio and old TVs. Not really used that commonly anymore. Fiber optic, people are probably familiar with this, of course, just using light. And then, of course, satellites. We could also mention Bluetooth as well, probably. Right, then, of course, there has to be a message, right? There has to be the actual data that we're sending. And finally, there just has to be a protocol. Now, if we just look at some of these briefly, so if we say, so HTTP. Now, that's going to be Hypertext Transfer Protocol. And then here, the S just means secure. Now, if we're thinking about this, of course, this is going to be about, this is going to be about, let's say clients and servers. And in particular, that's going to be what a web browser is going to be the client. And of course, right, the server, that's going to be a web server. So if we're talking HTTP, let's say here is the client, here is the server. Well, of course, right, that's going to be, that's going to be making an HTTP, right, or HTTPS request. Right, then, of course, the server is going to handle that, right, it's going to process it. Right, then, of course, it's just going to return with the result. And if we're talking about, a website, that's probably just going to be HTML content. And it could also be, CSS, JavaScript, right? It could be images, right? Videos. I guess just the basic content, right? HTML. Right, so we could also be sending over FTP. So FTP, the file transfer protocol. And basically, that's saying, right, So that's saying, right, either we're uploading files, right, or we're going to be downloading files. SMTP, I should probably look up this one, see what it stands for. Either, I think maybe it's the Simple Message Transfer or maybe Transmission Protocol. Basically, this is going to be about sending emails between 2 different email servers. So let's say if you've got so let's say you've got a Gmail server, and you're sending an email to someone with maybe like an Outlook or like a Proton Mail. Well, in this case, right, it's going to use SMTP, right, for the Gmail server to send this email, right, to the person with the Outlook inbox. Right, then if we say, well, POP3 IMAP, I mean, this is just going to be about, okay. So this is going to be about, okay, let's say receiving emails or downloading emails. And then, well, Ethernet, right, just kind of on a local network, just communicating, I guess, between the end device and the router, or I guess more technically, probably the switch. Right, so if we just see some of the transmission mediums, well, of course, Wi-Fi, right, it just kind of, says it here in the name. Right, okay, so if we look at this one, right, people are maybe not familiar with this. So this is going to be coaxial, and as mentioned, this was used for, well, the old TVs, right, and also, the radios. All right, then if we look at the final one, okay, sorry, not the final one, right, the third one. Well, of course, here, right, this is just using light. So, maybe people are familiar, right, okay, this is going to be fiber optic. Right, then if we look at the next one, so this is twisted pair, and again, this is what some people informally call Ethernet cables, and then, well, finally, just satellites. Now, this here is this here is, of course, not an exhaustive list. I mean, you could also have Bluetooth, you could also have some other wired connection. This is just some, common examples. Right, so then let's think then, right, if we say, well, data can be sent via the medium in 3 different ways. And again, when we say medium, well, of course, right, these are these are 5 different example mediums. Right, so first there can be simplex, and here, well, data is going to flow in one way only. And I think on the next slide we'll see an image of this. Right, then half duplex, so data flow is going to be bidirectional, but not simultaneously. So kind of only sending in one direction at a time. Right, then probably you can guess, well, then, kind of the next bit, okay, let's say the next version, right, it's going to be full duplex. And here, well, data flow can be both, well, bidirectional and simultaneous. So if we just see that, okay, well, simplex here, and okay, right, here's the pen. Of course, okay, so in this case, we can only send data, right, from the mainframe, from the server, I guess, well, to the monitor. Right, then, okay, so if we look at the next one, half duplex, so here I guess what we're saying, okay, so in this case what we can send between the laptops, but not at the same time. So either person 1 is sending, right, or person 2 is sending, but of course they're not sending at the same time. Then, well, of course, full duplex, I mean, what both of them can send, and both can send simultaneously. Right, so let's think of a kind of car example, right, if we think of cars on the road, then maybe you can guess how a simplex road would look. And of course, well, I mean, okay, so I mean, of course, right here it's just going to be a one-way road, which, people are probably familiar with, right? It's like a no entry, right? Just a one-way road. Right, then half duplex, so people can, probably think of this kind of situation. Sometimes they have this when they're doing roadworks, where, let's say here they're doing some roadwork, so what, okay, what they might do is they're going to let cars come temporarily, right, in this direction. And then I guess, I don't know, I guess, once a certain number of cars, or, after sort of a time period, of course, well, then they're going to, I guess, kind of block this way. And instead, of course, they're going to let cars go that way. So again, it's saying, well, of course, cars can go both ways, right, but not at the same time. Then if we look at full duplex, well, here, well, basically 2 roads. Of course, well, obviously, these cars here are going right, and while these cars here are going left. Right, so if we just sort of compare them then, well, full duplex is going to offer the most features. Right, half duplex is rarely used these days, and the main advantage is price. And I suppose, I mean, when we say most features, like, well, basically it's just talking, bi-directional data transfer, and of course, simultaneous. Right, there are actually specific cases where half duplex and simplex could be used, and even advantageous in some ways. So, e.g., like if we think about security, then if we only want data to go from one device to another, right, but not the other way around, well, in that case, of course, right, we could use simplex. And like if we go back, of course, well, that's kind of saying here, right, the mainframe. Now, if, for example, okay, so if we have some, critical data, right, some, sensitive data on this mainframe, and to be honest, like, I guess, well, now, like, rather than calling it a mainframe, people are probably just going to call it a server. So if we have some important data on the server, now we might want it where, let's say, the server can send to other people, but we don't actually want people accessing the server directly. And of course, that can be good for security, right? Since you're basically eliminating the chance of it being hacked, right? If you can only send the data, going from that device outwards, and of course, not having data coming in. So hopefully that makes sense. And then, right, if we look at message, well, so a message is simply the data, right? It could be text, image, videos, right, audio, something like JSON. I mean, if you don't know what JSON is, don't worry. I guess, I mean, it's commonly used for, web requests, but actually, also used for many other things these days as well. Right, messages will be sent during the messages just sent during the communication. Right then, if we look at the three different transmission modes, and these are kind of similar because while we what we said simplex, half duplex, full duplex, there's also going to be another three things. So one is unicast, and this is going to be one-to-one communication. Right then, there's going to be multicast, so this is a targeted signal from one source to multiple destinations. And finally, there's broadcast. So here the signal is sent indiscriminately. So I mean, okay, if we say indiscriminately, like basically, this just means in all directions. It's just sent out everywhere, right? So anyone who kind of tunes in, or I guess kind of connects, right, listens. So for example, e.g. the TV or radio, because if it, let's say this is our TV like tower or TV antenna. Well, of course, this signal is going to be traveling out in all directions. And of course, anyone with like a receiver or anyone with an antenna, they can of course listen in, right, no matter what direction they're in. So just to sum up again, so unicast, it's just going to be sending to one device, right, a one-to-one connection. Of course, multicast, right, sending to several, and of course, broadcast, just sending in all directions, right, sending to everyone. Then if we have a super quick look at some of the networking devices, right, so first there's going to be a hub. And actually, I mean, hubs are not really used these days that much. I think they've not really been used for like 20, 30 years. So these are going to receive messages and broadcast them to every device on a network. And really, I mean, these are going to be on LANs, to be honest. Just broadcasting to devices, within the same network. Now, the reason they're not used is, because of this feature here, right, because they broadcast. Now, in most cases, like, you're probably just going to want to send data to, I don't know, maybe just one device or maybe a couple of devices. You probably don't want to send to every device. And, so of course, one is just going to be privacy, right, security. Like, maybe the message is not intended for that person. Two, like, this is also going to slow down the network, right? If you're just sending data to everyone, of course, you're just sending massive amounts of data, right? So it's going to clog up the network, basically. Right, so then switches, these are just going to be an improvement on hubs, and basically they're the same. So they're just going to receive messages and they're going to, send them in the network. But rather than only being broadcast, they're also going to support unicast and multicast, of course, broadcast as well, right? If you like specifically want to. So again, right, if we say a switch, right, that's also just going to be on LAN. Right, now in contrast, so routers, they're basically going to be used to send packets between different networks. So here we say it's going to forward packets onto the next device, and this is based on a routing table, right, so that they can arrive at their destination. Now, don't really worry what a routing table is, but basically it's just going to say, so right, here's the IP address of the incoming packet, and then it says, so this is going to be a range, or let's say, 0, right, something, let's say, 2, like 100 or something. Well, it's going to say, so if this is the destination IP, right, then it's going to say, send out of like port A, for example. So it's just mapping kind of the incoming IP address, or the destination IP address, to the next place to send it to. So I say again, don't really worry if that doesn't make sense, because future videos we're going to look in a lot more detail. Right, bridges. So these are going to join two separate networks of the same protocol, and if you think about it, if we think of bridge, right? Let's say you have two islands, right? Maybe this island and this island. Well, of course, you're just going to use a bridge, right, to connect these islands. And that's kind of what we're doing here, where of course this is what network A or island A. Obviously, network B, right? Again, the bridge, right, just used to connect them. Right, then if we say gateway, so this is the entry and exit point to a network. It's going to convert data from one protocol to another. Now, one thing I will say, that if you mention routers, now if you're talking about a home router, then actually the kind of router you have in your home, it's also going to have the same functionality as a hub or switch. Of course, it also has the the functionality of a router. It's probably also going to have the functionality of these as well. Definitely a gateway, and possibly you might be able to configure it so it acts like a bridge. And the reason that a home router is going to do all of these things is because, if you think about it, so let's say like a normal person, right? Of course, when they buy their internet package, they're not going to want to have 5 different devices in their home. From the manufacturer's point of view, it kind of makes sense just to bundle everything together into a single device. Just to make it easier for the customer. So I think that's why a lot of people get confused about these things. Since okay, so I guess in kind of, you know, day-to-day life, right, people's experience, they actually think, well, hang on, like a router actually does, you know, all of this stuff as well. But yeah, if you're talking kind of technically, right, I guess, yeah, technically you would kind of call these, right, different devices. All right, so if we just start looking at the different topologies then, right, the first one is point-to-point. Right, so point-to-point, yeah, maybe as the name suggests, it's going to be a direct connection between two devices. And this connection, well, it could be via twisted pair, yeah, those kind of Ethernet cables. Right, of course, well, it could be Wi-Fi, fiber optic, yeah, etc. I suppose Bluetooth, because often you'll, for example, pair your Bluetooth. I don't know. Okay, yeah, let's say you'll pair your phone with your, you know, laptop via Bluetooth. Or yeah, maybe pairing your headphones, right, wireless headphones, yeah, with your phone, right, for example, via Bluetooth. And of course, yeah, that's just a direct connection. Right, so here we say, well, transmission could be simplex, well, half or full duplex, but since there's only one connection, then I guess we say, well, the message can only be sent unicast, since, well, I mean, yeah, of course, if you think about it like that, I mean, there's not another device to send it multicast to. Likewise, of course, we can't really broadcast, right? There's only one device. Right, so if we think of some of the advantages, yeah, maybe you can have a think about this. Well, one is going to be secure, because, well, if we say eavesdropping, now eavesdropping, I mean, this just means someone listening in. So let's, for example, go here and, okay, here's the pen. Right, I'm just going to call them H, right, just say a hacker. Now, in this case, like, it's actually going to be difficult for this hacker to listen into the conversation. I mean, in reality, you know, they would actually need physical access to the wire. I mean, yeah, okay. So, of course, right, if it's a wired connection, they would need physical access. If you're talking Wi-Fi, Bluetooth, right, probably a little bit less secure. Although if we assume that, I mean, hopefully it should be encrypted, right, then, of course, well, they're still going to need, you know, the key, right, the decryption key, yeah, the password. Yeah, of course, in order to actually make sense of any of that data. So, yeah, I think that's why it's quite secure, again, because, yeah, the direct connection. So because of this security, well, you can then use it to connect, well, critical or specialist servers together, right? E.g., okay, so yeah, let's say we have a bank. Now maybe the bank has a database of like all the transactions, and let's say, I don't know, yeah, they have a file server that can, you know, be used for storage. Well, what you might want to do is you might want to connect this database, right, with the file server, and of course you can then use that to store. I don't know, okay, well, you can use that to store the sort of daily transactions of, you know, everyone in the bank, right, all of their purchases, right, all of their deposits, yeah, all of their withdrawals. And of course, again, like, so the, yeah, okay, sorry, right, the advantage of connecting these together is that, well, of course, since it's, you know, point to point, it's going to be difficult for someone to actually, you know, kind of listen into that conversation. Right, it's also going to be fast and reliable, and, well, of course, yeah, this is because you've just got a dedicated connection, right, there's kind of no interference, right, no collisions. Right, lower congestion, since again you only have two people using the line. Yeah, so I think that should make sense. Right, but if we think the disadvantages, well, one, we can say, you know, it's not general purpose. We can only use it to connect two devices together, which, if you're talking about sort of general, you know, kind of general everyday use, probably we want to connect, you know, more than two devices. Right, there's also no redundancy, right, there's a single point of failure. So, of course, if okay, so right here it is. Okay, so, okay, right, if this central line goes down, well then, of course, you know, the whole thing just breaks. Whereas if we actually look at some other networks in a minute, right, let's say we sort of connect them, you know, through like this. Well, if this one goes down, you know, then we can actually route it this way. Yeah, so whereas if we have point-to-point, well, of course, we don't have that backup. Right, and we also say it's expensive because, well, we're going to need dedicated connections between each device. Right, then if we look at the next one, so this is also quite simple, the bus topology. Right, this is going to be a linear topology in which the ends do not rejoin and are terminated with a terminator. Right, and, well, this is represented with a black circle. Now, I think we'll see what that is in a minute. Right, messages have to be broadcast along the line, and, well, that's in red, since, yeah, generally that's a bad thing. Right, hence anyone can intercept them, right, even if they weren't the intended recipient. Now, again, you know, assuming this is encrypted, which, yeah, I think it probably says, yeah, okay. So if we say, right, assuming the message is encrypted, well, that should mean that the other people shouldn't be able to actually understand them. Again, of course, right, unless they have the decryption key. However, they can still actually see, you know, like which, okay. So, right, okay, let's say they can still see which devices are actually communicating. And they can also see other, well, I guess we can say metadata, right, about, for example, how long the communication lasted, yeah, how much data they sent. And of course, you know, based on this, right, you can kind of make inferences, yeah, maybe about, you know, what kind of data they're sending, for example. Right, so if we see an example, well, I mean, here we just got, what, 7 different devices, right? It doesn't really matter what they are. So let's say, for example, this laptop here. Yeah, this laptop here. So if it's this, right, let's say if this laptop wants to make a request to the server, well, basically what it's going to do, it's going to send this electrical signal here, and I'm drawing it as a squiggly line because, well, it's going to be a voltage, right? Of course, it's just going to be an electrical signal. Right, and then, well, what's going to happen? Of course, right. I mean, this voltage, well, one, it's going to go left down the wire, or yeah, sort of down the central bus lane. But then, of course, I mean, it's also going to be going this way down the wire as well. Now, the problem with this, of course, this signal is also going to be intercepted by this workstation. Of course, where is it? Okay. So, of course, well, the server will actually get this signal. Okay. So the server will get this data, but of course, so will every other device on the network as well. Like, if we think about these, kind of black things at the end, right? Well, these are the terminators. And the reason we have these terminators, where is the pen? Okay, here we go. Right, because, well, what's going to happen is, right, okay, if this electrical signal gets to the end, right, if we don't have the terminators, well, then it's actually going to reflect back. And when it reflects back, well, then we're going to get interference, we're going to get data corruption. Since we've just got, all this electrical signals, right, going back and forwards. So what we're actually going to say, well, these terminators, like, basically they're just a resistor, they're just something with a super high resistance, and that's just going to absorb the electrical signal, right, so it doesn't get reflected back down the line. Right, then let's ask, well, why is it called a bus topology? So, maybe you've sort of figured out, right, that, well, there are, of course, some similarities with a bus route. So we say, well, messages travel along the line, right, like a bus travels along the bus route. Right, we say, well, the devices are kind of like bus stations, or bus stops. Right, then the terminators, well, they're the start and stopping point of a route. So I mean, well, it's kind of like when you're on the bus, when you're on the subway, and I'll also say, what, the terminating station. So it's kind of the same thing. Right, and then, well, I think terminators, we said, right, these are just a device with high resistance. And, well, of course, again, the reason for this, well, it's going to absorb the electrical signal. Right, otherwise it's going to reflect back down the line and create interference. Right, so if we see some of the advantages, well, it's going to be semi-resilient. And we say, well, a fault in the node or a link connecting a node to the bus, won't prevent communication between other nodes. So what that's saying, well, that's saying, for example, this one, right, let's say this workstation just, has some fault, right, goes offline. Well, then of course, let's say the server. I mean, what this server can still communicate with, I guess this sort of workstation B, right? So again, if this workstation goes down, well, the other devices can still communicate, right? Doesn't matter. Likewise, right? If this connecting thing, right? If this goes down, if this wire, stops working, well, again, of course, the other devices can still communicate. Now, the problem with the bus line, like maybe as you can imagine, is, well, let's say here, right, if this central bus line goes down, well, if this goes down, then, well, I mean, the whole network just goes down in that case. So that's why here I've said semi-resilient, because obviously, well, in some cases it's resilient, but other cases, right, it's going to be, I guess, kind of vulnerable. Right, I mean, it's also going to be relatively easy to implement. You just need, a central bus line and just, connect the devices directly to it. Right. And so I mean, right, so here then I've put this in blue because, well, when we say efficient, I mean, it's kind of sort of, again, semi-efficient. I mean, this is going to be, less fast, right, compared with, say, the point-to-point, right, or compared with, for example, mesh, which we'll see in a minute. But yeah, I mean, I guess we can say, well, for small networks, it's kind of, I guess, like, good enough, in most cases. Right, also we require less network cable, right, therefore it's going to be cheaper, right, compared with, e.g. star or mesh networks, which we'll see in a minute. Right, and it's also going to be easy to expand because, well, we simply add a device to an existing line. So let's say, for example, we go here. Well, if we want to add a new device, let's just say here. Well, of course, we just put that device there. Then of course just add a wire just connecting to the bus line. So there's not really much configuration, right? It's quite simple to add. Right, however, some of the disadvantages, well, I mean, as we mentioned, well, I mean, it's sort of okay for small networks. However, as you probably guessed, right, it's going to be slow for large networks. And this is because, well, if you think, okay, they're all sharing that same bus line, and actually, right, only one person can send at a time. So what that means is that, well, the other devices have to wait, okay, for this person to stop sending, before they start sending. And if of course, if you just have like 3 devices, maybe that's okay, right? If you have, hundreds of devices and only one of them can send at any one time, Well, yeah, I mean, as you can imagine, right, it's, you know, just going to grind to a halt. Right, also, well, as mentioned, right, potential for eavesdropping, since, well, everyone can read the data. I mean, it's just broadcast. Now, again, like the reason I put this in orange, well, because okay, so if you think, right, if we're using encryption, and yeah, if I can spell encryption, then, well, yeah, again, so okay, while they can actually see the encrypted data, you know, they're not going to be able to decrypt it. So yeah, they're not going to actually, okay, right, they're not going to be able to see the contents. Right, however, they will be able to see some metadata, like who's communicating with who, or how much data they're sending, yeah, what times they're sending the data, you know, various other things like that. Right, also the identification of the problem is difficult, since if there's a fault on the central bus line, then it's kind of difficult to actually determine exactly where that fault is. Now, probably you might be able to realise, and yeah, can I just erase all of this? Right, so for example, okay, so let's say if, you know, this workstation stops working, well, you can probably make an inference that, well, yeah, okay, so we can say, well, either it's going to be an error with this actual workstation, right, or it's going to be an error, you know, with this actual connecting line. Now, if, for example, it's the actual bus line itself that goes down, and let's say, for example, there's, okay, here's the pen. Okay, right, so let's say there's an error here. Well, at this case, like, the whole network is just going to go down. So it's kind of difficult to determine, well, like, how do we know, right, okay, is the error at this part? Yeah, maybe the error is here at this part. Yeah, it's kind of difficult to determine, like, the exact point of the bus line, all right, where the error occurred, since it, well, yeah, again, you know, the whole network just crashes, right, just, yeah, stops working. Right, then we can say, yeah, okay, all right, so I think this one is probably the biggest disadvantage, right? This is going to be a chance of collisions, right, hence the packet loss is high. And when we say collisions, well, like this one we'll actually look at in more detail again in a future lesson. But basically, this is where you have two devices sending at the same time. So let's say, right, this is our line, right, this is A and B. Again, right, okay, this is, you know, connected up here. And let's actually use a different color for this, right, let's say blue. So, okay, all right, so, okay, let's say A is sending something on the line, and that's obviously going along the line. And let's say at the very same time, well, B is also sending. Now, you know, okay, so let's say when these signals meet, well, of course, that's going to be a collision. And yeah, I mean, this is just going to cause, well, yeah, the what interference. I mean, I guess you can call it corruption, but I think interference is going to be the best word. Right, and then, well, this we'll actually see briefly here. Again, right, talk about it later. And the thing to note, actually, right, collisions are not going to be an issue for star or mesh networks, right? They're only for bus. Also, point-to-point is also not going to have a collision. And yeah, well, okay. So point-to-point is not going to have a collision, right, if it's full duplex. Now, in most cases, it will be full duplex. I mean, half duplex, I guess you can get collisions, right? That's why, of course, yeah, you only have one device sending it, you know, at a time. Right, so, well, I think here we said, yeah, it's when two devices transmit at the same time, right? Therefore, the signal's going to, well, it's going to, you know, collide, right? It's going to cause interference, right? That's going to corrupt the signal. So, if we look at an example here, then what it's going to be, well, constructive and destructive interference. So, I mean, maybe from physics, people have looked at this, right? Well, constructive interference, all right, that's going to be what when the two signals are in phase, and then when they're in phase, well, yeah, okay. So, I mean, basically, well, then we're just going to add the wavelengths. Sorry, okay, all right, we're going to add the amplitudes together, right, in order to get, you know, this new, yeah, I guess, well, this new kind of, you know, resultant wave. Right, whereas, okay, if they're out of phase, well, then, of course, they're just going to cancel, right? We're going to get destructive interference. Right, then if we look at the next one, so, well, the full mesh topology, right, each node is going to have its own point-to-point connection with all others, yeah, as you can see here. Right, transmission, okay, transmission is usually going to be full duplex, and messages can be sent as, well, unicast, multicast, or broadcast. And if you think about that, and let's use a different color, since, yeah, that orange is a bit hard to see. Well, right, of course, you know, okay, let's call this one A, or this one B. Now, if A wants to send to B, well, of course, right, they're just going to send it along this wire here. Likewise, okay, let's say A also wants to send to C. Well, of course, yeah, they can simultaneously say to, well, of course, yeah, they can simultaneously send to, you know, A and, to B and C. Likewise, of course, you know, if they want to send to all of them, what, yeah, B, C, D, and E, well, of course, yeah, they can do that, right, in order to broadcast. Right, so we say, well, if a connection is unavailable, yeah, maybe the wire is broken, right, then the message can be sent along another path. So, of course, well, this is going to make it resilient. Now, let's say, for example, I don't know, this one, right, D. Now, if A wants to send to D, but, you know, of course, right, yeah, okay, so let's imagine this wire is just broken. Well, then, of course, well, I mean, either it can send it to this one first, you know, then send it here, Yeah, or of course, well, you can send it to this one, then this one. Yeah, obviously, well, yeah, obviously this one, this one, this one. Yeah, I mean, just, many different routes. Right, so let's think then. I mean, in many ways, this sounds good. It's fast, it's secure, right, it's reliable. Yeah, we've got, the different paths. But of course, there's actually going to be a reason like why this is not used in real life. Okay. So I mean, obviously, well, this is used in real life, but why it's not kind of the main or the most common one used in real life. So probably if you just look at this, I mean, what you notice, there's a huge number of connections. And what this means, well, basically, you're going to require too much wire. And often it's actually usually not required to have a direct connection between two different devices. So let's say you've got a network. Okay. So let's say here you've got a sort of router, right, a switch in the middle. Now let's say here you've got a sort of like person A, just some random member of staff. Likewise, person B. Well, in most cases, this person, what they're probably just browsing the internet, right? Maybe they're playing a game, right? Maybe they're I don't know, like watching some videos, whatever. Like YouTube. Like they're probably not actually like directly communicating with this device, right? I mean, they're probably just sort of using the internet. So in that regard, like it's usually not actually important to have a point to point right connection between the actual end devices. Usually this would be for more important devices like servers. Now let's try to think of a formula that we can use to calculate the number of connections. Now in the exam they're actually never going to ask you this, but yeah, maybe it's just an interesting thing to try. So I think the easiest way to do this is actually just to kind of try by example, right? So let's just make a table, right? And, well, this is going to be the number of devices, right? 2, 3, 4, 5. So let's say, right, if we have 2 devices, well, then there's just going to be 1 connection. So let's write 1 connection here. If we have 3 devices, well, then we're just going to go 1, 2, 3 like this. Okay, that's going to be 3 connections. If we have 4 devices, well, of course, then we're going to want to connect this to the other 3. So yeah, then we're going to want 6, right? 3 more connections. Right, I guess let's do it here. Okay, so if we have 5, well then of course we just want to connect this to the other 4. Okay, that's going to be 4 more connections. That's going to be 10. Of course, okay. So so if we just look at this, like probably you can see a pattern. Right, so here we're just going to plus 2. Right here we're going to plus 3. Right here, of course, we're plus and 4. Well, of course, yeah, the next one's going to be 15. Right, the next one's going to be 21. Now, maybe you can actually realize that, well, what this is doing, like basically it's just calculating the, I guess it's going to be the arithmetic sum. I think that's what they call it in maths. Where of course, 1 plus 2 plus 3 plus 4 plus 5. I guess, of course, up until n. So if we actually think of that, well, the formula then is just going to be this. And so if we look at an example, well, let's say we have 100 devices. Well, that's going to be this many connections, right? This many wires. Which, of course, this is just not realistic. If you're thinking about like an office, for example, right, with 100 employees. Right. So okay. So I think, as mentioned, then because of this huge number of wires, then this is usually used to connect more important devices, right? Things like servers, like routers, switches, bridges, right? Connecting these things together. So I guess what you could have, where let's say you have something like I don't know, okay, maybe this is our server 1, right? This is server 2. Okay, right, let's say server 3. Now, like these ones could be connected using a mesh, but then if we just have I don't know, well, okay, let's go C, right? I mean client computer. Of course, this one could just be connected via just a sort of single connection or something. So that's kind of what we're saying here with the partial mesh. Right, we don't need to connect every device point to point. Right, for example, a web server would probably need to be connected to the database server and an email server, right? But the web server probably doesn't need to be connected to the print server, since generally you're not accessing a website, and when you access that website, it's going to send some print, some print request. I mean generally that doesn't really happen. Right, so if we think some of the advantages, then it's going to offer full duplex communication. And of course, full duplex, 1, it's going to be fast. Obviously 2, it's just simultaneous. Right, it's also going to offer 3 transmission types, unicast, multicast, broadcast. Right, it's going to support high traffic loads since multiple devices can transmit data simultaneously right across different wires. Of course, that's kind of saying, okay, so let's say if A wants to send to B, and let's say C wants to send to D, well, of course, they're going to be sending on different wires. Unlike, for example, the bus network, or the bus topology, where of course they're all having to share that same central bus line. Right, it's also going to be resilient since failure of one line, or yeah, I guess kind of one wire, right, only causes that particular wire or line to go down. Right, other routes can then be used. I mean, yeah, hopefully that makes sense, right? That of course, okay, let's say this one goes down, then in order to send, that same route, well, of course, first we're going to go to this device, right? Then of course we just go to that device. Yeah, just rerouting. All right then, well, just some more advantages because yeah, there's actually a lot for this. What's going to be okay. Let's say it's going to have good privacy or high privacy, also security, right, due to the dedicated connections. And if you think about that, like what that's saying is, well, if yeah, okay, all right, so let's say, all right, this is A, this is B. Well, if A is sending to B, then these other devices like C and D, I mean, they're not going to be able to listen into that. Now, of course, the only okay, so I guess the only time that's not true is okay, here it is. All right, so let's say if this connection goes down and instead, for example, we have to go via this intermediate, well, then of course, right, in this case, this one can listen in. But yeah, I mean, generally that's not really a common situation, like I mean, probably the connections are working in most cases. Right, we also say, well, adding additional devices doesn't disrupt data transmission between current devices. Yeah, we just add it, we just like add in the extra wires. Yeah, we don't need to actually like modify the entire network. Right, the fault identification is easy since you know exactly what line is down. Of course, what if yeah, okay, again. So of course, right, if A and B can't communicate, well, therefore, of course, it's this line that's down. Yeah, I think hopefully that makes sense. Right, and finally, it says no centralized authority, which honestly, this is kind of the same as high privacy. Yeah, it's just saying, well, your data isn't having to go through some central device. Right, it's going to make eavesdropping harder. Right, however, some of the disadvantages, well, probably you can guess, right, it's going to be expensive, right, due to the large amount of wiring. Right, also building and maintaining is going to be extremely difficult, even with a relatively small number of devices. And I suppose, yeah, again, that's because, well, of course, there's going to be like hundreds of different wires, right? It's going to be complex. Right, there's also high power consumption, right? Again, just because, well, the amount of wires, the amount of connections. Right, this one I've kind of put in orange. Well, you could have redundant connections. Right, even if a partial mesh is used. And I mean, like, yeah, okay, so, right, the reason I say redundant is because, well, let's imagine, right, again, A and B. But what happens, for example, yeah, okay, so let's say if this device is just turned off, or yeah, if this device is actually, not really using anything at this time. Now, in that case, I mean, then you've got this entire wire where, just like no data is actually flowing through. Yeah, just because the device is turned off, the device is not active. Yeah, it's not, it's not really requesting any data. So it's kind of a little bit wasteful in that regard. Right, then if we look at kind of the final one, well, of course, yeah, before the hybrid topology as well. But well, okay, I guess we can kind of say like the final distinct network type, or yeah, the distinct topology. Right, so here then in star, well, and actually this is what you're going to use, in your home, right, when you just have a home router. So you're going to have a central device, and in particular, well, okay, let's call it a central switch. And all devices will go through this switch in order to communicate with others. Right, so switches will support Unicast, Multicast, Broadcast. Right, and well, yeah, okay, so I think as mentioned, right, hubs are only going to support Broadcast, and of course, well, that's why they're rarely used these days. So if we see here then, well, hub and switch, okay, so, and to be honest, I mean, let's just call it a switch, really. Right, so switch is going to be in the middle, and of course, well, let's say if, okay, right, this A wants to communicate with B, of course, well, first they're going to send it to the switch. Right, then the switch is going to look at, I mean, really, okay, so the switch can either look at the IP address, right, or the MAC address, it just depends on the network. And then, well, based on this, right, then it's just, okay, here we go, right, well, yeah, right, of course, then it's just going to send out the correct, I guess the correct ports, right, in order to send it to the correct end device. Then, as mentioned, it says, well, switches, they will store a list of IP and MAC addresses so packets can be sent to the correct devices. And actually, if we think about this, well, again, right, this is just how a home network works. Because what you're going to have a router in the middle, and all right, yeah, all right. So again, if we're talking about common day-to-day usage, right, people will call it a router. However, if you think, okay, this is a router, okay, but also with the functionality of a switch, yeah, just combined into one device. So I think here, okay, well, let's just call it a switch, because again, if we're talking about like an internal network, right, if we're talking about a LAN. Well then, yeah, a switch is just going to be used to, send, I guess, send packets to devices, within the LAN, or yeah, send frames to devices within the LAN. Right, so we say, well, the switch, right, is going to store a list of either the IP or MAC addresses. And then based on that, well then of course it's just going to route it to the correct device. And well, as mentioned, right, this is the most used in practice. Just using home, right, office, classroom environments. And I think we said this. Right, so what we can say, well, I mean, it's kind of semi-resilient, right? If one line goes down, then only that end device will be cut off. However, if the central switch or central hub fails, well, then the whole network stops working. And I think, I mean, hopefully that makes sense, right? Of course, well, that's indicate, right, if this line goes down, well, then, of course, only that, right, only this device is going to be cut off. Whereas, of course, right, if this, central hub or switch goes down, well, then, of course, right, I mean, no one can communicate. Right, so again, let's think of some of the advantages. Well, again, it's going to offer full duplex communication. Again, right, 3 transmission types, Unicast, Multicast, Broadcast. Right, due to the hub nodes having point-to-point communications, right, there's going to be no collisions. So unlike the bus network. Right, well, each device only needs one I/O port to connect to the switch. And when we say I/O ports, probably we'll see that in a future lesson. But basically, I mean, that's just going to be, okay. So it's going to be, the port, right? It's going to be the socket. Basically the physical kind of the hole, the connection, where of course you actually plug the cable into. Again, so it's going to be relatively easy to implement. Now, if we're thinking like a home network, well, I mean, you just turn on the router, right? Turn on the switch. Of course, type in the sort of Wi-Fi password. Right, then of course it's just going to directly connect. Likewise, even if you wanted like a, what sort of twisted pair connection, well, of course, you're just going to plug in the twisted pair cable right into the back of the switch. Of course, then plug it into your, desktop, PlayStation, Xbox, right? Whatever device you've got. And of course, well, I mean, actually, in that case, right, it should be even easier because, well, then you shouldn't even need to type in the password. It's just going to automatically connect. Right, it's also going to be easy to identify the fault, right, due to the point-to-point links. And hopefully that makes sense because, well, what we're saying is, of course, kind of as mentioned, right? Let's say, for example, okay, if this one stops working, well, obviously we know that, of course, this is therefore the line that's broken. Right, we will say, well, it's going to be fairly resilient due to the point-to-point links. Although, of course, well, what if the central hub or the central switch goes down? Well, then, of course, the whole thing just breaks. Right, disadvantage, well, I guess the obvious one, again, right, central switch, central hub fails, right, the whole network fails. Right, it's also going to be more expensive than the bus. Okay, so I guess it's going to use more cable than the bus. However, it's going to be cheaper than either the full or partial mesh, so it's kind of in the middle. Right, if the switch is under high load, well, then of course it's going to get slow, right, if we have many devices connected. And I mean, I guess kind of everyone knows this, right? If you have like a sort of big classroom, big office, right? If everyone is sort of using the router simultaneously, okay, right, of course then it's just going to slow down, right? I think everyone knows that. Right, extra hardware, so switch hub are going to be required compared to the bus topology. Although to be honest, I mean, if you just buy a switch, a router, I mean, it's going to be pretty cheap. It's generally not that expensive, right? Not that complex. And I mean here, kind of as mentioned, right? The performance just depends on the switch. Like if you have some, super powerful, super expensive, switch router, then it's probably going to be quite fast. If you just get the sort of cheap, if you get the cheap one, and if you try to have 20 people simultaneously connecting to it, then probably the performance is not going to be too good. Right, then finally, if we just look at the hybrid networks, this is just going to be a combination of topologies, right, as mentioned. So if you look at this diagram, okay, try to figure out what two network topologies they've actually combined. Right, so if you've had to think about that, then what you can say, there's going to be a central bus line, and I guess here you can see that here. So then with star networks connecting to it, and of course, here we go. Right, of course, this is going to be the star topology, right, just with, of course, the end devices connecting to it. So let's try and think of an example, right? Suppose we have some important devices like a file, web, email, and print server, right, as well as some regular user PCs, then suggest a possible hybrid network structure. Right, so I'd say if you want, pause the video, have a think, right, maybe even try to draw a diagram, and then obviously just resume the video once you've done that. Right, so let's take a look at a possible approach. Right, the important devices could be connected as a mesh, right, either full or partial, while the PCs could be connected to switches via a star topology. So if I just draw a diagram, let's go F, right, that's the file server. well, let's go W, right? That's the web server. Well, let's go E, right? Just the email server. So here, what? Okay, so well, yeah, I think this one, you know, I've already mentioned this actually, you know, in the previous example. But we can say, well, okay, these can be connected right via a mesh, and in this case, I'm going to use a full mesh, right? I mean, there's only 3 devices. Yeah, sorry, there's only 3 servers. Right then, I guess actually, okay, these would actually also all need to be connected to the switch. So yeah, let's actually just connect those to the switch as well. Now, if we're then talking about the sort of individual user PCs, right? Okay, let's go. Yeah, PC. Now we can say what these PCs can just be connected to the to the switch here. And I guess kind of if I do another one here, and then like yeah, probably in this case you can kind of see how it looks like a star. But yeah, I mean, to be honest, you know, even if we only had these 2 devices, right? Even if we only have right this one and this one, I mean that's still going to be a star topology. Yeah, even though it sort of maybe doesn't actually look like a star. Yeah, I mean if you actually think about it, right, it is still kind of operating like that. Right, so let's just have some recap questions then. We want to say what are the 5 requirements for a digital communication system? And again, you know, pause the video, right, have a go. And yeah, obviously, well, of course, right, resume once you've thought about that. So here what it's going to be, well, there has to be a sender, there has to be a receiver, right, message, communication medium and protocol. Right, then let's say, well, what are the 3 ways a message can be transmitted between individual devices? Yeah, I guess individual, right, not individually. So if we think, and yeah, okay, so okay, right. If we're talking about individual devices, then this is not talking about, for example, like Unicast, right? Well, of course, the other 2, right? This is going to be talking. Well, if we see, right, okay, it's going to be what simplex, half duplex, and full duplex, right? Then the next one. So what are the 3 ways a message can be transmitted between multiple devices? So one of these I've just mentioned, and hopefully you can remember the other 2, right? So well, unicast, multicast, and broadcast. Right, then let's try, yeah, okay, all right, so can you list 4 network topologies? Right, what are the advantages, disadvantages of each? Again, all right, pause the video, have a think. And yeah, this one, there's going to be a lot. Right, so if we say point-to-point, well, the advantages, it's going to be secure, it's fast, reliable, right, it's also private. Again, all of these are because, well, there's only, you know, a direct connection, right, therefore, yeah, all of those 4 kind of features. However, that's also kind of a disadvantage, right? I mean, we can only communicate with 1 device. Right, of course, it's also expensive, right, if we want to have, you know, many point-to-point connections in the entire network, since we're needing lots of wires. You can probably also say that bandwidth utilization is low, because let's say you have a wire, and, well, yeah, all right. So again, you can have a situation where, okay, let's say the other device is turned off, or yeah, they're just not communicating, and in that case, well, right, okay, so of course you've still got that wire, right, but you're just, well, you're not using it, right, you're not utilizing it. Right, then if we see, well, the bus, so the advantage is, well, it's going to be cheap, right, easy to implement, also easy to expand, right, of course, easy to add new devices into it, since, well, you're just going to, you know, connect it up, connect it to the central bus line. Right, this one I'll put in blue because it's kind of a, well, okay, like, I don't want to say an advantage, I mean, it's kind of like a moderate advantage, I guess. If we're talking about small networks, then I guess you say, what, the speed is good enough, you know, it's not terrible. In this way, again, kind of semi-resilient, because if a node or link is unavailable, right, well then the other devices are still going to be able to communicate. However, of course, if the central bus line goes down, well, again, you know, the whole network just breaks. Right, however, the disadvantage as well, I mean, the obvious one is going to be collisions, right, so only 1 person can send at a time, right, otherwise you're going to get the interference. Because of this, well, it's going to be slow, because of course, what the different devices have to wait until the line is empty. And actually, right, if we think about this, okay, this we're actually going to look at in a in a future lesson. So, okay, well, yeah, if I just say it now. So this whole thing, well, CSMA CD, right, that's going to be carrier sense multiple access with collision detection. And basically, that's just going to be how a bus network manages the collisions. Yeah, that's on the syllabus, right? What they often ask about that in the exams. Yeah, difficult, like 4 or 5, right, maybe even 6 mark questions. Right, also eavesdropping, so this is what just people can listen in. Now, I've put this in orange because, well, if the data is encrypted, right, it should be okay. Although, of course, as mentioned, right, they can still see who's sending to who, how much data, yeah, what time, you know, just various sending patterns. Right, and we'll see, well, the problem identification is difficult. Now, again, or as mentioned, okay, if the problem happens, okay, let's say on these, you know, connecting wires, or yeah, the sort of, you know, end workstation, well, then it's easy. But if the problem happens somewhere on the bus line, well, how do you know if it's here on the bus line, you know, or if it's, for example, here on the bus line? Yeah, okay. So again, the whole bus line just goes, or yeah, the whole bus line goes down. right? Therefore, it's difficult to pinpoint the exact, the exact place of the error. Right then, if we look at full or partial mesh, so this I guess we see lots of advantages. Right, it's getting fast, resilient. It's resilient because we can reroute the packets. If one of the lines goes down. Right, it's going to be private, secure, and that's because offers obviously point-to-point, right, point-to-point connections. Full duplex, of course, fast, right, simultaneous. Again, right, the 3 transmission types: unicast, multicast, broadcast. Right, adding new devices and identifying faults is easy because I guess we're just going to add new connections. Although, okay, so while I've said it's easy, like in the sense of it's not kind of technically complex, you can think it's kind of complex if you have hundreds of different devices, hundreds of different wires. So in that regard, for big networks, I guess it is actually going to get quite complex. But also no central authority, so kind of good for privacy. Right, it's going to be expensive, and that's because of course you need lots of wire, and I suppose actually so difficult to manage. Again, that's kind of for large networks, which is kind of actually in direct contrast to being easy to add new devices. Right, and it's going to be high power again because lots of wire. Right then, finally, star. So if you remember star, this is actually what's used most commonly in real life. And the reason for that, of course, there's going to be quite a few advantages, and the disadvantages are quite minor. Right, so star, there's going to be no collisions, and that's because again you have the sort of direct connection right with the central switch. It's going to be fast, right, again because of that direct connection. Right, it's going to be relatively cheap. It's going to use a sort of relatively low amount of wire. Although I think they do say it uses more wire than the bus network. Right, setup for identification is easy because again, of course, we just connect the devices right to the central switch. Right, it's going to be full duplex again, 3 transmission types, right, unicast, multicast, broadcast. Right, it's going to be resilient, so if the end device or connection drops, because what we can say is that okay, so right, okay, if we say that if one device stops working, let's say this is the switch here. Now let's say for example alright, A stops working, C can still communicate with B, right? So of course one device doesn't stop the other devices from working. Right, however, because because all packets go through the central switch, then if we have high load and I guess if we have a cheap switch, right, then of course it can be slow. Right, we've also got a single point of failure, right, again in that single in that switch, and I guess we can say it's going to be slightly less private, less secure. Now basically that's saying okay, so because everything is going through the switch, if let's say I don't know, maybe that switch gets infected with malware, right, or if for example okay. Right, if we say, for example, that switch is kind of owned by someone else, then potentially they can actually see all the traffic that's going through that. Alright, so I think just a little bit more then. Alright, so let's think about which communication mode, right, simplex, half duplex, full duplex, and transmission mode, unicast, multicast, broadcast, does each topology support. Right, so of course, here are just the different topologies, and try to think about this. Right, so if you had a thought, let's see the answers. Right, so if we actually look at these, they're all going to support all the communication modes, right, except for the bus, which only supports simplex and half duplex. And if you think about that, that's because okay, so of course, as mentioned, right, we can't have 2 devices sending on the bus at the same time, right, otherwise you're going to get the collision, right, when they meet in the middle. Right, then if we look at the transmission modes, all of them, right, they're all going to be all except point-to-point, which is only unicast. And of course, point-to-point is only unicast, right? Just because you only have 2 devices, right? Of course, therefore you can't have multicast, right? You can't have broadcast, right? Since again, of course, right? There's only actually 2 devices, right, to communicate. Alright, guys. So I think it seems then that that's everything. Again, probably a super long video. Some of the descriptions, probably not too good, but hopefully it's kind of semi-useful regardless. And of course, if you have any questions, right, just ask in the comments, and hopefully see you again in the next video.